Welcome to today's lesson, Logarithmic Functions. During your investigation, you should have learned that logarithmic functions are the inverse of exponential functions. So let's look at the definition of the logarithmic function. A logarithm base b of a positive number x satisfies the following definition. When x is greater than 0 and b is greater than 0, then y equals log base b of x is equal to b to the y is equal to x. So notice that the base of the log is the same as the exponent. In a logarithm, the exponent is isolated, and what's inside the log is outside in the exponential function. Example 1, Part A. Rewrite 4 equals log base 3 of 81 as an exponent. So an easy way is we know that the base of the log and the base of the exponent should be the same. So I like to say we can slide the base, and that gives us 3 to the 4th, and then we drop the log on the other side, and 3 to the 4th is equal to 81. Part B, rewrite 1/5 equals 5 to the negative 1 as a logarithm. So remember now, the base of the logarithm has to be the same as the base of the exponent. We isolate the exponent, which means this has to equal negative 1, which means then that 1/5 has to go inside the logarithm. Example 2, find the exact value of log base 2 of 16 by rewriting it in exponential form. Alright, so I'm just going to take log base 2 of 16 and I will set it equal to x. So now I have a logarithmic equation that I can convert to an exponent. So I'm going to slide the base and drop the log, and I'm going to get 16 is equal to 2 to the x. Well, we know that 16 is equal to 2 to the 4. So if 2 to the 4 is equal to 2 to the x, which means that x equals 4, or that the solution to log base 2 of 16 is equal to 4. So another way we can look at this is we can ask ourselves, what would I have to raise 2 to get 16? Well, 2 to the 4th equals 16, which means log base 2 of 16 equals 4. Now we're going to talk about two special kinds of logarithms, common logarithms and natural logarithms. A common logarithm is a logarithm with a base of 10. We write log base 10 of x just as log of x. So if you don't see a base, you assume that the base of 10. Now the corresponding exponential function is if y equals log of x, it has to be the same as 10 to the y equaling x. A natural logarithm is a logarithm with a base of e. We write log base e of x as ln of x, or natural log of x. So if y is equal to ln of x, that means that e to the y has got to equal x. These two special functions can be found on your calculator. Example 3, use the definition of common and natural logarithms to simplify. Well, 10 to the log of 12 is the same as 10 to the log base 10 of 12. Because 10 to the x and log base 10 of x are inverses, they cancel each other out, and this is simply equal to 12. Part B, the natural log of e squared. Well, this is the same as log base e of e squared. When the base of the log and the base of the exponent are equal, they cancel each other out, and this is equal just to 2. Example 4, evaluate the following without a calculator. Log base 3 of 1 over 27. Well, let's think about 1 over 27. We have log base 3 of 1 over 3 cubed, because that's what 27 is. And I can rewrite this again as log base 3 of 3 to the negative 3, because 1 over 3 cubed is the same as 3 to the negative 3. Now because the base of the log and the base of the exponent are equal, they cancel out, and our answer is negative 3. Part B, log of 1 plus 7. So there is nothing written as the base. That means that the base is 10. So this is the same as log base 10 of 1 plus 7. Now think about this. What would we have to raise a base of 10 to get 1? Well, the answer to that is anything raised to the 0 exponent is equal to 1. So log base 10 of 1 is 0, and 0 plus 7 is equal to 7. And part C, natural log of e to the negative 0.225 minus 3. Well, remember, natural log is the same as log base e of e to the negative 0.225 minus 3. When the base of the log equals the base of the exponent, they cancel out. So this is negative 0.225 minus 3, or negative 3.225. Example 5, use a calculator to evaluate the natural log of 15. Round to 4 decimal places. So find the natural log button on your calculator and evaluate the natural log of 15. This is approximately equal to 2.7081. So some important relationships we learned here is that if we have log base b of 1, no matter what the base is, as long as you raise it to 0, it'll equal 1. So log base b of 1 is equal to 0. So that means that the log of 1 is equal to 0 and the natural log of 1 is equal to 0. Another thing we saw was that if we had log base b of b, if the base of the log was what was inside the logarithm, they cancel each other out, and so this is equal to 1. So that means then that log of 10, or log base 10 of 10, is equal to 1, and the natural log of e, or log base e of e, is equal to 1. That's all for now. Thanks for watching.